with New Tech Press with our final report on the music conference that was held last week in San Jose for Magma Design. Last July, in the interview we did with Rajiv, he talked about how Magma was going to be highly focused on the area of analog and mixed signal design. To that level, they announced Titan ADX last year. And they're coming out this year with version 2.0 with a specific focus on flex cells. This is the next step for Magma. It's going to be to help people design building blocks, analog IP that can be used again and again, which is a big goal for EDA.
So I'm responsible for product marketing, business development of our custom design platform, which is called Titan. So we're going to talk about today, and Rajiv will announce that during the keynote, is Titan ADX, or Analog Design Acceleration, version 2.0. So new version of that. This is a product we have announced last year. So there are two things that are primary emphasis today. One is we are announcing availability of flex cells. This is essentially an area that we've been working on for the last 2 years. Flex cells are something like our users would know, higher level design enablement building blocks for analog. Okay, so for analog design, typically the building blocks today are P cells or parameterized cells. These are transistor level cells, and what we're doing is in combination of our ADX software and in combination of flex cells, we are raising the level of design enablement for custom analog design to a building block level, essentially op-amp and LDO and band gap level designs. And so designers can actually use this model-based top-down hierarchical approach to do a very high efficiency, very high productivity designs for analog and custom.
So what are users doing now that this overcomes?
So users today use, as I said, basic low-level primitive such as transistor, and it works well. I mean, today the designs are being produced by that. But by raising the level of abstraction, you encourage the design reuse. Because one of the bottlenecks in analog design today is the number of analog designers, and the expertise is very, very scarce and very high cost. The second thing is the time it takes for these designers to create new designs because of the available flow and methodology is really long. And last but not the least is that it is essentially for analog design customers, it's very tying. Once you design a chip with a one process, then you're tied to that process. There is no portability, scalability, migrability. The version 2.0 for Titan ADX essentially allows and encourages the hierarchical top-down design that allows people to take their analog IP from one process to another, that allows analog designers to reuse their analog blocks, and at the same time raise the design enablement level, design abstraction level to the building block RTL level. End result of all this is, number one, productivity improvement, 30-40% productivity improvement compared to what they do today. And number two is typically, because we are optimizing the entire design flat, we get 30-40% power reduction, up to 30-40% power and area reduction.
Is there anything else going on with this new product?
Absolutely. So second key announcement as part of this new version is ability to take schematics directly from your existing schematic environment into Titan ADX and map it, size it, optimize it for your specifications, your process, and directly output the size schematics, essentially schematic in, schematic out, to do automatic sizing, automatic mapping, automatic optimization of your analog linear circuits. So you don't have to worry about creating any cells for that matter. Just give us the schematic, we'll optimize it. And this is all math based, so we don't have to run the simulation. The effect is essentially the same, reusability, portability, migratability, scalability, with probably 50% improvement, 30 to 50% improvement in productivity.
Okay, and this is still also in the field right now?
This is being used by a couple of our customers right now.
Excellent. Well, thank you very much.